Okay, welcome everybody. Zdravím vás v Bratislave, ale omlouvám se, nebudu mluvit po slovensky, ale po anglicky. Moja slovenština není dosť dobrá, abych vám mohl porozprávať o Azure tak, abyste mě to aj věřili. Takže zase jdem zpátky na angličtinu, ale můžete se mě opýtat po slovensky, jestli budou otázky. So, I'm Peter Koen. I work in the Azure engineering team. So my team reports directly into Jason Sander, who is the VP for all of Azure product development. And my team is globally distributed, and we have the coolest mission there is in Microsoft. We get to work with all the new toys on all the big complex projects. So as the customer advisory team, it is our mission to go and work with the biggest and most complex Azure projects worldwide. And I have the honor of leading the team that does this for Europe, Middle East, and Africa. And to give you an impression of what our team is working on, I brought you a small video of one of the projects that my team has delivered.
It's more than the driver. It's more than the car. For Lotus F1 team, the winning edge starts with the cloud, powered by Microsoft Dynamics, Azure, and Office 365. The team can analyze and share data from over 200 sensors, working in sync to make the calls that make the difference between winning and losing. This is the Microsoft Cloud.
I'm the technical guy, you're the GM, you get the money, that's not fair. So, why would a team like Lotus, who are all about speed, agile, rapid decisions, choose a product like Azure? Well, the answer is very simple. Same as in racing, in IT today, a lot is about speed, the scale at which one you can execute, and the cost that you have for that execution. And with cloud computing, we are now in the era of hyperscale computing, where a couple of years ago, if you would manage a data center with 1,000 CPUs in there, you would be the local hero. Half the city would bow to you and would say, wow, what an amazing data center you have with 1,000 CPUs. So let's just do a quick show of hands. What do you think? How many CPUs in Azure work only on Microsoft internal compute properties and services? So who thinks we have about, let's say, 5,000 CPUs running our own website and public services? Okay, I cannot trick you, it's too easy. Let's try 50,000. Who is for 50,000 cores? Nothing? Somebody already getting worried. Help me, I have 50K cores. What about 500,000 cores? Okay, we got a few. Let's double that. What about 1 million? No one? Well, actually, that's the scale that Microsoft-owned properties that are running on Azure consume today. We are running 1 million cores, running Microsoft services from Office 365, Skype, internal SharePoint sites, file shares, Active Directory, OneDrive, Xbox, Titanfall runs on Azure. So you name it, every new Microsoft project runs on Azure. And when you run 1 million cores for internal workloads, then to make a big difference on your bottom line, all you need is a small change in your effectiveness. So 1% change in being better in how we run our own cloud can mean an annual difference in the double-digit to triple-digit millions for Microsoft. And now all this optimization that we do will go and benefit our customers. So basically, why would you want to bet your business on the Microsoft cloud? Very easy, because we are betting our business on the cloud. We are right now the only cloud provider that can run on enterprise-grade SLAs, enterprise-level support at a hyperscale, providing thousands and thousands of cores to our customers, and we're the only provider that has a true hybrid platform. That means you can run identical services on-premises and in Azure and connect them to build an integrated cloud solution. And the industry is starting to recognize that. Gartner rated Microsoft in all 4 categories So infrastructure as a service, platform as a service, cloud storage, and virtualization as a leader in the industry. And also our customers are starting to seeing that. So some nice numbers from the last fiscal year. We now see 80% of the Fortune 500 companies are using Azure. We are signing up 10,000 new customers a week that are opening up Azure accounts. So I hope we'll have a couple hundred more after today and go and start the trial. There will be Microsoft guys here from Slovakia willing to help you and happy to help. We have about 350 million users in our Active Directories. And the really, really good news for us is people don't get it yet, but Microsoft really loves Linux and open source. And 1 out of 5 machines on Azure is an open source Linux VM running non-Microsoft workload. And if you want to make me really happy, bring more. Make it 2 out of 5 or 3 out of 5, even better. I love working with Linux on Azure. And a couple more of those impressive numbers. If you look at this slide, I will not read through all of them, but Azure really has matured from the child project that came out of a weird idea from the product team to a mature product that is a viable solution for the market and for our customers. We are running real-life services, like, for example, Skype is running on Windows Azure. And I would argue that Skype is probably perceived as one of the most reliable internet services out there. Everybody is using Skype. I have nobody seen that would complain about the quality of Skype. So if it's good enough to run Skype on a global scale, maybe you want to give it a try for your service as well. So when you think about cloud and you look at these impressive numbers, it means that our business is changing. When I move from an enterprise IT, where I worry maybe about a couple hundred, a couple of thousand seats, to cloud, then I start to worry about a solution that suddenly can reach millions or even billions of users. Can you imagine being an IT admin that has to manage a server farm like Facebook and then think, hey, how do I do this in my data center with the support level that I'm giving every single user in my enterprise today? Things like that are not possible on a cloud scale. In a cloud scale, you need to start thinking differently. Instead of being the owner of a lot of iron and a lot of electricity, you want to be the owner of a strategic service. You want to move from a fixed cost investment where you buy hardware, you buy network equipment, you buy power equipment, air conditioning, buildings, hire people, hire security, etc. You want to move to a consumption model where you say, I don't care how much it costs to run the air condition, to get the right power line, to get the right security company. All I care about is that the service for my web page, for my database, is as reliable as the water that comes out of my faucet. How many times a day do you think, what SLA do I have on my water supply? Will water flow constantly? What if there is an interruption in service? No, you don't worry. And that's exactly where we want to get with cloud computing, that you can trust the cloud, that your service will be fine. It will be there when you go in, activate the service. It's like turning on the tap and the water will flow. So will the data flow. And now let's talk a little bit about how we move forward with those services. That means you have quite some challenges in your own environment. So as an IT pro, you need to start thinking about, hey, how does this impact my enterprise? So how do I integrate my existing IT investments? I have this database on premises. I have my SharePoint sites on premises. I might have some legacy solutions on open source machines that I don't know how to move. Then the next question is, okay, what do I do with all the different operating systems and solutions? I might have stuff running on Windows Server 2008. I might have this one box with 2012. Then I have the CentOS and the Red Hat box and the SUSE box in there, and it's all running different solutions. And then all that stuff has to be secure. And so far, I could convince my boss that it's secure because I locked the servers behind my door in my office. That they are sitting in front of a 5-year-old firewall, in front of a 7-year-old router, with plenty of loopholes in the firmware, nobody cares. It's secure, it's locked in my door. And that thinking is starting to break up, because security and flexibility is no longer having the iron next to your seat and being able to touch it and say it's secure because I can feel where the hard drive is. It's about it has to be secure the way it's built, the way it's designed. So when we look at Azure, we need to address those 3 questions to make the cloud a viable option for the enterprise. We need to start thinking about, hey, how do I integrate it into my existing environment? How do I enable my enterprise to move from an everything in my data center situation into a partial cloud situation and ultimately maybe even a cloud-only situation? What are the workloads that allow me to take advantage of the scale and the cost benefits of the cloud without compromising security that I perceive to have in my data center? And those are the things that we are trying to address, and I would argue quite successfully addressing with the Microsoft Cloud OS story, which is pretty much saying, hey, everything that we have built for the cloud, we also have available on premises. Windows Azure is built on the same Windows servers that you can use in your own data center. So there's no reason why you wouldn't be able to move a workload from a data center that you own into Azure, or if you see the need for that, move back into your own data center. Not that I have seen a lot of people that would want to do that, but the option would be there. And so with this Microsoft Cloud OS platform, basically the same way that you use virtualization on your own machine, you just create the virtual image, upload it to Azure, and start using the virtual image of your machine on a server in our cloud. The same way you authenticate against Active Directory, you can open an Active Directory on Azure, have that federated with your local Active Directory, and use a single sign-on solution, which, by the way, no other cloud provider currently can provide you, that has a transparent single sign-on between on-premises and the cloud. At Microsoft, we don't even know if an internal service that is run by MSIT is running on Azure or in their own MSIT data center on campus, because we just sign in once on our machine with our Active Directory user, and then it transparently authenticates us against all the other services. The only thing where I notice that this is going on, because I know Azure and I see when the protocol in the backend is doing something like loading a certificate, but for the regular user, it's absolutely transparent. They don't see if the app is running on the box where they're sitting at in the data center or in the Microsoft data center. And also the interesting thing is we try to make it as easy as possible for you to use those tools. So basically anything that you can use today to work with your computers and your machines in your local data center, you can use the same technology to use on virtual machines in Azure. So be it PowerShell, Visual Studio, SQL Server Management Studio, all those things are available to work with Azure, and Azure is perfectly integrated, so you have exactly the same experience as you would have on premises. So once we have managed to move machines into the virtual machine on the cloud and have them parked in the cloud, it comes about what can I use these machines for? What can I run there? And no, it's not just Microsoft technology. We love to integrate other tools. So if you're a developer, you can write code in .NET, PHP, Java, Python, whatever language comes to your mind, C++, go and write the code. It is supported on Azure. We support third-party systems that can run on Azure and can be used on Azure. We support operating systems from the open source world. There's even products from commercial competitors are available. So you can use Oracle databases or IBM servers on top of Azure. Actually, you can even bring your on-prem license if you already bought the Oracle machine and move that license to your Azure solution. So you don't need to buy new licenses. We have deals with Oracle and IBM that enable that flexibility for your solution. And we have services like the Enterprise Mobile Device Management Service that allows you to manage non-Microsoft devices if you absolutely insist on having Android and iOS and similar in your environment, we are happy to manage them through an Azure-based environment as well. Now, those were the two easy parts. How do I move into virtualization in the cloud, and how do I integrate other developer solutions, other companies, our competitors? Now comes the tough question when it comes to cloud discussions. So who remembers from the three things that I showed before, what's the last question that an enterprise needs to solve? Security. And that's usually where the cloud conversation starts turning a little bit awkward, because security is this thing where everybody knows it must be important. Nobody has really understood what it means, but it's a great buzzword to make your job secure and explain why you're not selling that server and why you need 5 new routers and 3 new modems and 10 new servers. So the way we handle this with Azure is, thinking has changed a little bit. Security doesn't mean anymore I can lock my laptop behind a closed door and it will be secure. Because today in our connected world, where, as Arthur C. Clarke said, we have a man working from, Tahiti or Bali, then there is no physical proximity security. It's about security in the communications protocols. And that means we can look at security in a way, how do we make computing trustworthy again? It's not about somebody stealing my hard drive, because they will not get into that data center and they will not find my hard drive. But how do I make the solution secure in terms of trustworthy, that the user will trust my web page, my online business, that I'm working properly with his data, and that my credit card details will not be hacked and my personal information will not be leaked. And the way we do this on Azure is that we use standard industry certifications where we have third-party auditors come in, look at the Azure environment, and certify that Microsoft is following certain procedures and protocols for the best practices in security of data center. We use our own Microsoft best practice and best of breed software to support firewalls, routers, etc. in the data center. And we have innovations like digital right management to secure content. We have secure communication channels. We can allow you to build VPN channels between your environment in Azure and your environment on premises, so that it feels that as if the servers in Azure would be part of your private cloud on-prem. They're connected through a secure tunnel. And we are very transparent about this. Anybody can request our audit logs, can ask for the certifications that we have. We have an Azure Trust Center online on azure.net, and there you can look at all the certifications and request additional information through the support channels if you want to know what exactly is happening. And still, the conversation sometimes is a little bit difficult. So I would invite you, if you have doubts that Azure is a secure solution, grab me or one of the other Microsoft employees here, and let's have a conversation in the break about what you think security should be for the cloud and how we think that matches with what we have. Because if you tell us what your procedure is, what is your understanding of security, we can have a dialogue and we can show you how does it map onto features that we have in Azure. And so far, I have not found a single situation where we were not able to map your desire of a secure process into the technologies that we have available on Azure. Okay, so with that, I would say Azure delivers enterprise-ready clouds. We have the 3 main ingredients that you need for building your own cloud recipes, which is in integration with on-premises, heterogeneous solutions, including our competitors, and a great security story. Now, all of that needs a physical foundation. And the physical foundation for us is our worldwide network of data centers, connectivity, and we have, for Azure, some of the biggest data centers in the world. Microsoft actually has twice as many sites online as Amazon, and 6 times as many sites as Google. And what I want to do next is show you a little video how it looks like in one of our mega data centers.
Microsoft's cloud is comprised of a globally distributed data center infrastructure supporting over 200 online services, including Azure, Office 365, Bing, MSN, Windows Live, Hotmail, and Xbox Live. More than 1 billion customers and 20 million businesses in over 70 countries use these services each year. Today, we're going to take you on a brief tour of a Microsoft data center and share how we ensure trustworthy and reliable cloud services while continuously improving performance, scalability, and efficiency. Microsoft operates a global array of data centers and edge compute nodes, all connected through a high-speed network. Our major data centers house tens of thousands of high-performance processing and storage servers in high-density racks. Chillers and air handling equipment ensure precise control over environmental conditions. Uninterruptible power supplies, or UPS systems, and vast banks of batteries help ensure power remains continuous in the event of a short-term disruption. Emergency generators provide backup power for extended outages and for planned maintenance, and can operate the data center with on-site fuel reserves in the event of a natural disaster. A high-speed, robust fiber optic network connects servers within the data center and connects each data center with other major hubs and internet users. Edge compute nodes host workloads closer to the end users to reduce latency and increase overall service resiliency. Microsoft ensures high availability through multiple layers of redundancy, advanced monitoring and incident response, and geo-redundant backup and graceful failover capability, all managed through our geographically distributed Microsoft Operations Centers operating 24/7, 365 days a year. We also deploy one of the largest implementations of Microsoft System Center in the world, and we use our own data repository called Scry to record power consumption and allow precise cost allocation to our internal business groups. Power Usage Effectiveness, or PUE, is the measure of total data center power consumption divided by IT, or critical power, and highlights how much power is consumed by supporting infrastructure versus the power to operate servers. A typical industry data center has a PUE of approximately 2.0, where the amount of energy consumed for the facilities and supporting infrastructure equals the energy to power the servers. Our latest modular data centers have reduced PUE significantly, typically in the range of 1.15 to 1.25. PUE is a useful metric, though we look holistically at all components of the data center and optimize for performance per watt consumed in total. Our modular approach to data center designs helps us rapidly scale to meet new customer demand. And our innovative use of free air cooling helps improve efficiency and sustainability. Security at our data centers employs outer and inner perimeters with increasing security at each level, utilizing a combination of technology and traditional physical measures. We maintain hundreds of controls across multiple levels of operations. At the data centers, technical security elements include two-factor access control, badge readers, extensive camera monitoring, and integrated alarm systems. Traditional measures can include perimeter fencing, security officers, and locked server racks. Data secured in Microsoft's data centers is classified based on its sensitivity and protected accordingly. In addition to maintaining best-in-class operations processes, we routinely bring in third parties to verify our capabilities, resulting in ISO 27001 and PCI certifications, SAS 70 Type 2 or SSAE 16 attestations, and FISMA certification. Microsoft's award-winning cloud infrastructure powers the cloud services our customers and partners use every day and delivers these services with trust, reliability, performance, and efficiency.
So when I visited an Azure data center for the first time, I was driving with a couple of colleagues in a bus, and we were going over a small bridge, and we started joking, man, this looks like a tank mode. I didn't know we were building castles. And then we go in there, and the operator takes us for the tour, and the first thing he says, and we have great security. You might have noticed our tank mode outside. And everybody went silent in the room. So yes, our guys take security really serious. So now that we have seen the physical, the hardware component, the base of our data center, the stuff where billions of dollars were invested over the last years, let's look at the virtual, the software stuff that we built on top of it. So the basic building block of Azure is a virtual machine. The virtual machines run on the physical infrastructure of the Azure data center. They are controlled by something that we call the Fabric. The Fabric is our automation software that takes care of distributing the workloads and ensuring that the machines are in a healthy state, moving workloads to different machines if a machine becomes unhealthy, managing capacity within the data center, distribution within the data center, failover, and things like that. In those virtual machines, you can then put your own workload and run your own environment in a virtual machine. We call that infrastructure as a service. The drawback with infrastructure as a service is it's your virtual machine. You are responsible for everything that happens in that machine. We will not interfere with your machine. It's exactly the same as what you would have on premises on a physical box. So you are responsible for backing up your data, for doing failover, for saying if your machine is in a healthy state within that VM, but you have full control. You can run any software you want in there. The next step then is cloud services, where Microsoft takes over some of the management of the service. You only provide us with your business logic and your compute workload, and we run it for you. So that means we can take care of things like automatic failover, automatic scale out. We can take care of running data in redundancy rings so that if the primary fails, we have secondaries taking over, that we have an automatic backup mechanism, etc. And then on top of those cloud services, we build higher value services that are easier to consume for developers and for our IT pros worldwide. So things like, for example, websites, which is an abstraction on top of Internet Information Server, which allows you to build fully scalable web pages without having to worry about how to set up that IIS underneath. And then we have additional services like, for example, mobile services. So there we have things like a notification service, a device management service, things like that. And those four groups of high-level services use a lot of sub-services within Azure and have a lot of additional add-on services. So I'll just put them here in smaller boxes. So we have data services from classical relational databases to NoSQL databases to big data technologies like the Hortonworks distribution that is used of Hadoop for HD Insight, which is the Microsoft deployment of Apache Hadoop. We run caching services for you, data recovery services, etc. Then the next thing we have are network services. So we provide network load balancers, traffic managers, where you can say, based on specific characteristics of the workload, let's automatically decide if traffic should go to Europe, to the US, or to Asia, and endpoints for VPN connectivity so that you can build VPN tunnels into your load, and then all kinds of high-level services. So, for example, media services to allow encoding and streaming of videos, Event Hub for massive ingestion of messages, for example, in an IoT scenario. So when you have millions of devices deployed and you're reading sensor data, then we have the services that would allow you to ingest and in real time compute the analysis on, let's say, 1 million events a second from sensor data. And that's the kind of scale that's impossible to build in your own local data center, because you need the global scale to build solutions like that. So, and once we have all those components together, then on top of that, you can use PowerShell, .NET, Java, PHP, whatever your favorite Kool-Aid for development is, just use it on top of those services. All services are exposed also as REST-based services. So whatever the language, as long as it knows how to consume JavaScript object notation or a REST-based API, you're good to go and can use all of our services. So that means, in reality, how do you build an Azure solution? You look at those high-level application services, where it's cloud services, caching, identity, high-performance computing, analytics. Then you have data that needs to be stored to be consumed by those services, so classical databases, NoSQL databases, or big data storage. And then you have the bare-bone infrastructure underneath. And when you build an Azure solution, you start from the bottom. You pick your solutions from you start with the apps, what you want. I want caching, identity, a cloud service, and a table. Then let's throw in some data and some network. And with those components, you then build the solution connected through VPN to your local enterprise, and it becomes part of your environment. And we are constantly working on moving those solutions forward. Originally, this slide deck contained slides with hundreds of individual features that we have built in the last 12 months. And I said, look, guys, I'm not going to stand out here for 2 hours reading out feature names, because I'm sure you can read them online if you're interested. I just want to touch on 4 big areas where we innovate on Azure. We are investing a lot of money into infrastructure services. So we are working on ways to make the applications in Azure more resilient, more scalable, and better performing for you. So we build in stuff that is impossible for you to build in your own data center, like, for example, geo-replication. So we will allow you to put data into a data center in, let's say, Europe, and because you want high security, if something happens, your data needs to be safe, we allow you to replicate the data through our own backend into a data center in Asia, that if something happens, you have a copy outside of that country where you originally stored it. Or if you have data that needs to be distributed globally for performance reasons, because you say once the guys in Asia wake up, they need to have the data locally, we can do geo-replication over to our Asian data center to make the data available where it's needed. We also invest a lot in application services. So just recently, we started showing the preview of a document-based database service, DocumentDB. We are building things like the Event Hub for Internet of Things scenarios, or Azure Stream Analytics, which is a service that allows you to do real-time correlation of data on multiple input streams. So you could say, hey, if simple scenario, let's say I have a device that reports that a car has hit a bump on the road. And if 5 minutes later another car reports that there was a bump at exactly the same coordinate, then I might have damage in the road and it was not driver error, the first bump. To correlate this, that's very difficult if you're looking at tens of millions of events per second. But with technologies like Azure Stream Analytics, we can give you the technology to build this kind of applications. And when we look at the future scenarios of Internet of Things, those will be impossible to build with a local data center, because you will have to have technology that allows you to correlate events from your devices in sub-second timing on a global scale. Then we're also investing in databases, because once you have all those events from your solution hitting the cloud solution, you need to analyze them somehow. You want to know how many bumps in the road did I hit from Bratislava to Žilina. Well, I stopped counting by the time I reached the freeway here. Sorry to have to say that. But the device will not stop counting. It will put that into big databases. And then you might want to analyze with, hey, how was the weather that day? Did the weather have any influence on the amount of bumps in the road that I counted for the first 10 kilometers? And for those things, we work highly on things like big data analytics, data storage technologies, etc. And last but not least, you'll say, hey, I'm not on a business trip. This was a special personal trip. I don't want everybody to see my trip data, so you need identity management, access management, control over your data on a global scale. And those are the things where Microsoft is investing heavily into Azure to make sure that your solution scenarios will be safe and best performing and highly scalable in Azure. And with that, let me close with one last slide saying, I strongly believe we have the most complete cloud out there. We have consumer services like Skype and Xbox, business services from Office 365 to Dynamics, and all of that is built on Azure as the base platform. And if Azure is good enough to run Office 365, let me help you run your business on Azure as well. Let's bring the scale of Office 365 to Azure. Nothing would make us happier than seeing you and your business grow bigger than Office 365 on Azure. And with that, thank you guys. It was a pleasure to be here. And I'll hand over to my next speaker. Welcome, Jan. Thank you.